Hello, my dear children. Welcome to my channel, Sudhir Chemistry. But in this atomic structure, till now we have seen initially what is the Dalton's atomic theory, where we have seen some limitation of Dalton's, and based on that we have entered for the fundamental particles, and now we are going to see discoveries of these fundamental particles. So the first topic which I am going to discuss now, and that one is with a discovery of electron. This one is the discovery of fundamental particle. That is a discovery of electron. Actually, electron, it was discovered by whom? J.J. Thomson. J.J. Thomson. But the name electron, it was proposed by Stoney. The name of the person is Stoney, who proposed the name of the electron. Now, for to understand the discovery of electron, we have to take the discharge tube. See, beta, this I am going to take now a discharge tube. So indirectly, I am going to explain you a discharge tube experiments. Actually, it is a tube made up of a glass. See, beta, it is a tube made up of a glass, closed at both the end, having the electrodes. This is a negatively charged electrode called as a cathode, and on the other side, it is having a positively charged electrode called as a anode. Beta, one is the cathode, another one is the anode, and this tube should be filled with the gas. And to fill the gas, we are having some inlet here with a knob to what you can say, the maintain the pressure of the gas present inside the tube. Let us say I am taking beta here hydrogen gas, and that to be at low pressure. We are taking the hydrogen gas at the low pressure, that is 0.01 mm of Hg. Beta, mm called as a millimeter of mercury, that is unit of pressure, and both these electrodes are attached to the battery, and from the battery we are sending the current, and the current which one we are sending, it is at high voltage, nearly 10,000 volt of the current we are sending through the battery. But by passing this high voltage of current through the tube containing the gas at low pressure, the name of the person is a Crook. But he observed something new in this tube. What he observed, I'll tell you. But what he observed is, he kept here a one of the screen is there. Let us say, beta, this is a screen, and this screen is called as a fluorescent screen. The screen is called as a fluorescent screen. Crook, he kept the screen behind these electrode. This is a which electrode, beta? Anode. This is a fluorescent screen, and this screen is made up of a zinc sulfide, ZNS. What he observed, this screen is there, na? By passing a high voltage of current, this screen will start to glow. Means what is the importance of this ZNS screen? If any minute particle will come and it will hit to the screen will glow. So Crook observed some glowing part on the screen, and he thought that some particles are coming from here and they are hitting on here. So he called that particle which is coming from right hand side to left hand side, and he called these particles are nothing but the particles coming from the cathode, and he called this particle as a cathode rays. He called that particle as a what, beta? Cathode rays. So now, actually, what is a cathode rays? Really, these cathode rays are coming from the cathode plate, or it is coming from somewhere, that we are going to learn. But now at present, I will tell you. Crook, he observed some particles are coming from the cathode and they are hitting on the screen, and the screen will start to glow. And this particle, he called it as a what? Cathode rays, right? Means we can say, beta, the rays are emitted from the cathode are called as a cathode rays. So I should call this nothing but it is a rays emitted from the cathode. I'll write the point beta here. Ray emitted from ray emitted from cathode plate are called cathode rays. Right? This is observation made by whom? It is observation made by the Crook. Right? So cathode rays, because the gas present in it at the low pressure. Take a screenshot of it. Now we can say, beta, this is a what is the properties of the cathode rays now. So now we can discuss about here key properties of cathode rays. Beta, properties of cathode rays. Can we say this is a rays coming from the cathode plate? So the first point we can make that we can enter or we can write the cathode rays moves from cathode to anode. The cathode rays, the cathode rays moves from where beta? It moves from cathode to anode. This is the first point. That is the important properties. Second property we can say these rays we cannot see beta. So we can say these rays are invisible, but their behavior can be observed. These rays, these rays are invisible because we can't see these rays, but but their behavior can be observed. But their behavior can be observed. But how their behavior can be observed? Because see, when these rays are coming and when it hit to this fluorescent screen, the screen will start to glow. So I should say their behavior can be observed. Acha, how it can be observed? So we can see it can be observed with the help of fluorescent screen. With the help of with the help of fluorescent CENT with a fluorescent screen. This is the second important property. Now third property we can say now these rays beta they travel in a straight line. So point number 3 I'll say these rays these rays travel in straight line means these cathode rays they travel in what? A straight line. It is not like that when it is moving something will come here then it will take the turn it goes, no, not like that beta. So these rays are moving straight line means they are moving travel right or they are moving or travel in a straight line, and that to be this movement straight line only in absence of electric and magnetic field. Yeah, beta. That means in presence of electric field and magnetic field, beta, these rays never travel in a straight direction. Because suppose these rays are negatively charged, I don't know. Suppose if it is a negatively charged, one of the positive plate is here, one of the negative plate is here, and we applied the electric field. So while moving, what happened? As it is a positive plate, now this negatively charged particle attracted by positive, and then it moves upward. So that means initially move straightly, but applying the electric field, direction may change. Applying the electric field, direction may change. So these rays travel in straight line in absence of electric field and magnetic field. But in presence of electric field, they deflected in some other direction. Please take a screenshot. I will show you the diagram for you. Deflection of these by the electric and magnetic field. Now, but what we said here, these cathode rays they travel in straight line in absence of electric field and magnetic field. Actually, what happened, when we apply the electric field and magnetic field, how these rays will move. Let me explain you. Suppose these are the cathode rays. Suppose these are the cathode rays. And but we applied here electric field. Let us say it is a positively charged plate called as anode, and this is a negatively charged plate called as a cathode. I'll write beta this is the anode and another one is a cathode, right? Now beta what happened, suppose this is a cathode rays and let us consider this is the anode and this one is the cathode, right? When we applied the electric field beta, this rays goes up and it will hit on this point A. Because anode is a positively charged and these rays are behaving as a negatively charged. So I should say beta cathode rays are the negatively charged. By applying the electric field, it moves up means it goes towards the anode. Suppose if I will apply the magnetic field, let me explain you beta. Suppose this is a cathode rays, and we are applying the beta magnetic field like a north pole is here and south pole is here, right beta? So by applying the magnetic field, these rays it will move down and it hit on this point as a B. So these rays are deflected toward the south pole on applying magnetic field, and these rays are deflected towards the point A on applying the electric field. Indeed, indicate that beta these rays are negatively charged. So they are bending somewhere. They are bending somewhere by applying electric field and magnetic field. But in absence of, see what I wrote, in absence of electric field and magnetic field, these rays travel in straight line. Is it clear? Now beta, I will try to explain you exactly actually what happened in this discharge tube beta, and how this cathode rays really it is coming from cathode plate or it is coming from somewhere else, that I am going to explain you. See what is that one? Listen here now. But in this discharge tube we have taken the gas. Let me tell you beta, we have taken the gas. Which one? Hydrogen gas. And you know hydrogen gas should be written in form of H2. So this is a hydrogen bonded with the hydrogen. Initially we have taken the gas. When we applied high voltage of current, but due to this high voltage of current, it will break the bond. Due to high voltage of current, but it will break the bond between hydrogen atoms. As it will break the bond, now the initially which is a hydrogen will be there in the form of a molecule. Now it will be converted as a atoms. See beta, now it will be converted into what? Atoms. Okay, hydrogen molecule converted into atoms. But still this high voltage of current is coming from this plate, which plate? Anode, as well as coming from cathode plate. Why? Because we applied 10,000 volt of the current through this battery. Now due to that high voltage of current, now this atom which is present here, now it is going to be ionized, mean it loses electron, get the positive charge, electron comes here. Right beta, again due to this high voltage of current, this atom also loses electron, it will get positive charge, and this E negative come off. Now after that beta, it atoms will be converted into ions. What is that? H plus, E minus, H plus, E minus. And now you tell me beta, due to this negatively charged particle, it will be moving toward the oppositely charged plate. What is that? Anode. And this negatively charged particle, that is nothing but the what? Indirectly we can call these are the electrons. And these initially Crook observed all these things and he called these particular rays are called as a cathode rays. Now what we have to say beta? These cathode rays are nothing but the negatively charged electron. My question is beta, are these electron, means these electron either it is coming from the plate or it is not coming from the plate? So our answer should be what? These electron is not coming from this cathode plate beta, it is coming from only the gas. First point, means the point what we observed, that cathode rays, that is a negatively charged electron, cathode rays are are independent, but the cathode rays are independent on the cathode plate used in the experiment. But in this experiment, whatever the cathode plate we have to take, but these electrons, these cathode rays, that electron, they does not depend upon the cathode plate used in the experiment. So they are independent on the cathode plates used in the experiment. Second point, but is this cathode rays or electron? It depends on the gas taken in the tube. Let us say first example, hydrogen gas I took. Second example, but a gas I will take here as a nitrogen gas N2. But it is in the form of molecule. By passing high voltage of current, it will be converted into what? Atoms. It will be converted into what beta? Atoms. Afterward, these atoms will be converted into what? Ions. Let me say N plus, then E electron, again N plus, again E electron, and obviously this negatively charged electron will move toward the anode plate. Now my question is beta, electron coming from these nitrogen atom and electron coming from these hydrogen atom, are both the electron are same or we have to say differ? So our answer is beta, both the electrons are the same. Either the electron coming from hydrogen or the electron coming from nitrogen, it is same because these electrons are having same charge, same mass, right? So I should say one more point, that cathode rays, but cathode rays are independent. Is it clear? Cathode rays are independent on the nature of the gas taken in the discharge tube. Nature of gas taken in where beta? Taken in discharge tube. Is it clear? So cathode rays are independent of the nature of the gas taken in the discharge tube, as well as independent on the cathode plate used in the discharge tube. Means indirectly these cathode rays or these negatively charged rays is indirectly called as the what beta? Electrons. Is it clear? Please take a screenshot of this one. Hence beta we can say, I'll write here, hence electrons are the constituent particles of all atoms. Electrons are the constituent particles of all atoms. Means beta, either it is electron coming from any atom, the properties of that electron will be remain same. Hence we can say electrons are the constituent particle of all atoms. Right? Take a screenshot of this complete picture beta. Now after that we are going to see beta charge to mass ratio of electron. So J.J. Thomson, he is able to, actually what is in the charge to mass ratio? Charge means E, mass means M. This ratio of E by M, this is called as a what? A specific charge. This is called as a specific charge. But J.J. Thomson is able to, J.J. Thomson is able to calculate E by M ratio of the electron. Achha, how he is able to determine E by M ratio of the electron here? So E by M ratio of the electron can be determined based on the following, based on the following points. Based on the following points. What is that following point? First one. But let us say, this I will explain you. Suppose these are the negatively charged stream of particle cathode rays. And when we applied the electric field, that is a positively charged anode and negatively charged cathode. And here screen is there. But these negatively charged particle now by applying electric field, it moves upward. Let us say beta it moves on the point A. But now suppose it is having two negative charges are there. And by applying the electric field, what happened now? Instead of going A beta, it goes to somewhere as a B. Now again the magnitude of the charge it increases, deflection will be increasing. So what the first point he says that according to Thomson, that is greater the magnitude of the charge. The first point I am going to write beta. The first point which one I am going to write. Greater the magnitude, greater the magnitude on the charge, right? But a greater the magnitude on the charge or greater the magnitude of the charge on the particle, of the charge on the particle, greater is the deflection, greater is the deflection. I told you no beta, single negatively charged particle deflected less, more negative charged particle will be deflected more. So greater will be the deflection. And when the deflection will occur beta, greater is the deflection when EF, electric field and magnetic field was applied. These and these are applied. This is the first point. Second point beta, what we can say, you know this stream of this negatively charged particle called as a cathode rays, that is electron. Now beta, if E by M, if the mass of the particle will be lighter, means we can say lighter the mass of the particle, greater will be the deflection. So lighter the mass of the particle, lighter the mass of the particle, greater will be the deflection. Greater will be the deflection. Means beta, this deflection part, it depends on what mass of the particle as well as it depends on what magnitude of the charge on the particle. Again one more we can say beta, this deflection of electrons from its original path, it increases when the voltage will be applied more. So third point we can say, when applied voltage is more, when applied voltage is more, we can say deflection will be more. Is it clear, beta? Applied voltage is more, deflection of electrons from their from their original path will be more. From their original path will be more. Means see beta, deflections of these cathode rays depends on what? Magnitude of the charge, mass of the particle and applied voltage. Is it clear? Take a screenshot of these 3 points. Now beta, based on these above all the 3 points, that is the magnitude of the charge, mass of the particle, applied voltage, Thomson is able to determine the E by M ratio for the electron, and when he calculated this value for E by M ratio or specific charge of electron, it is a 1.75. But I think you remember in the table I gave for you 1.76 is there. Actually 7588 is there, but 1.76 into 10 to the power of, it is in coulomb per kg, right? 10 to the power of 11 coulomb per kg. This is a value called as a specific charge. This is a called as a what? Specific charge of the electron. It was able to determine by Thomson. Right, beta? Take a screenshot. Beta, now one more point is that the electron which is moving, the mass of the moving electron can be determined. I'll write one more point here, and this is a mass of moving electron. Mass of moving electron can be determined, but it can be determined by the formula m is equal to, actually m is a mass of the moving electron, m is equal to m naught by under root of, but what we are having, 1 minus v by c whole square. Actually what this m naught indicate, beta? M is a mass of moving electron. I'll write this m is a mass of moving electron. M naught is the mass of rest electron, right? And this v and c, actually v is the velocity of electron and c is the velocity of light. But this v is a velocity of electron and this c is a velocity of light. Velocity of electron is there and velocity of light is there. Okay, but if this v is equal to c, means velocity of electron is equal to velocity of light, then mass of the moving electron, it becomes infinity. If v is equal to c, what is the v? Velocity of the electron, and c velocity of light, then the mass of the moving electron is equal to what? Infinity. Because apply the formula here, 1 minus 1 0 beta, 1 minus 0 means something number by 0 become a what? Infinity. Is it clear? And better in the previous properties of the cathode rays we saw, no? There also we saw what is that? The cathode rays are independent of the nature of the gas taken in the discharge tube, as well as it is independent of the cathode plate used in the discharge tube. So we can say the value of E by M ratio, we can say beta, the value of E by M of cathode rays. Cathode rays means indirectly we are talking about the electrons, beta. The value of E by M of cathode rays is what? That is also independent of nature of gas. But a nature of gas used in the discharge tube, used in the discharge tube, as well as independent on, but as well as independent on cathode plate used in the experiment. Cathode plate used in the experiment. But did you remember what we saw in these experiments? When we are using the gas, either hydrogen gas, nitrogen, any gas, but a negatively charged particle is nothing but an electron. So that electron, it doesn't mention it is coming from which gas, and that electron is nothing but the cathode rays. So what we can say, beta, that cathode rays is independent of the gas taken in the tube, as well as it is independent on the plate which we are using as electrode, cathode plate. So indirectly cathode rays are independent of the nature of the gas used in the tube, as well as independent on the cathode plate used in the discharge tube. Means indirectly we can say E by M ratio for the cathode is also independent of the nature of the gas, right, as well as independent on the cathode plate used in the electrode. That means this shows that beta electrons are the universal constituent of all matter. Now point is not, place is not there, but I'll write beta. What is that? Okay, electrons are universal part. It means it is present on each atom, every atom. So electrons are universal constituent particles, universal constituent particles of all matter. In every matter it is having a element, and every element it is having a atom, and every atom it is having a electron. Means electron is present in every atoms. Is it clear, beta? Take a screenshot of this one. It's good. Beta, now I am going to tell you how to calculate the E by M value of ions with respect to hydrogen atom. See here, E by M value of ions with respect to hydrogen atom, that is equal to, but whatever the ions they give, first of all you have to write the magnitude of the charge. We will write the magnitude of charge by E by M mass. So we should write a relative mass, or we can say this is the mass number. Magnitude of charge means what, you know? That is the relative charge. It is a relative charge, and mass means it is a relative mass number. It is a relative mass number. Write on the formula, beta. One examples we will do for this one. Now you can see what a question is given. Find the E by M value of the alpha particle. But I wrote in the form of ion. You know, alpha particle is helium 2,4 we can write. But I wrote here as a 2,4 helium ion with respect to hydrogen atom. So I will go with this one formula. E by M value of the ion. Which ion? He plus 2 ion is equal to. But what is the magnitude of the charge? Are you able to see? Yes, 2. By mass number. What is that? 4. 2 by 4, 1 by 2, 0.5. Is it clear? But now based on that we are going to discuss some more. How that we can say key mass of the electron, how they have determined. Actually charge of the electron, you know, it is determined by the Millikan oil drop experiments. What is that? See here. Charge of electron, you know, electron charge, negatively charged, is the smallest electrical known charges, right? Or smallest known electrical charge, we can say smallest known electrical charge, that is a charge on the electron, and it is taken as a negative charge, you know, electron E negative. It is taken as negative charge. It is taken as better negative charge. Now Mulliken oil drop experiment, based on this Mulliken oil drop experiment beta, Millikan is able to determine the charge of the electron. So Mulliken oil drop experiments, Mulliken is able to determine charge on electron. He is able to determine what beta charge on electron, and charge on the, or we can say charge on the oil drop, each oil drop, it was always an integral multiple of charge on oil drop is an integral multiple of 1.6022 into 10 to the power of minus 19 coulomb. Actually, these things we are going to learn in detail. In physics, it is given better in molecular oil drop experiments. What is that? The mass of the electron is equal to, that is E. Electron, we can say that is the charge of the electron by E by M ratio of the electron. Now, what is the charge on the electron, beta? 1.6022 into 10 to the power of minus 19 coulomb by, what is the E by M ratio of the electron? E by M ratio of the electron, just now in previously we saw, what is that, beta? 1.76. Actually 7588 is there, beta. I'm writing 1.76 into 10 to the power of 11. Remember, 10 to the power of 11 coulomb per kg. And if you solve these value, I'm going to get 9.1 into 10 to the power of minus 31 kg. See, beta, with the help of these experiments, means with the help of Mulliken oil drop experiments, we are able to calculate the charge of the electron. E by M ratio already we got by the Thomson, and by taking the ratio of these two, I am able to find out what mass of the electron, that is 9.1 into 10 to the power of minus 31 kg. Right? Take a screenshot of this one. See, beta, here question is given. An oil drop has this many charge, 8 into 10 power of minus 19 coulomb. How many electrons does this oil drop has? We saw na, beta, oil drop means each oil drop, it is having a integral multiple of 1.6022 into 10 to the power of minus 19 coulomb. So now I should say charge on oil drop. What is the charge on oil drop? That is equal to 8 into 10 to the power of minus 19 coulomb. And what is the charge on one electron? 1.6022 into 10 to the power of minus 19 coulomb. So can we say, beta, this is the charge for one electron, then this is the charge for how many electron? Right? So it should be 8 by this value. So directly we can use now, beta, what? See, if it is a 1 electron, the charge is 1.6022 into 10 to the power of minus 19 coulomb. But now this many charge is there. So how many electron it should have? X, and do the cross multiplication. What will get, beta? X is equal to 8 into 10 to the power of minus 19 by 1.6 into 10 to the power of minus 19. That means if you do here, the value we are getting as a 10, beta, 1 by 2, 10 by 2, right, beta, 10 to 10 by 2, it is equal to 5. So how many electrons are there? It is having a 5 electrons. Or we can say one more method is there directly, beta. What is that? Charge means Q is equal to N into number of electrons. Now what you have to get N? N is a number of electrons, that is a Q by E. What is the Q value we are having? That is a charge, total charge. 8 into 10 to the power of minus 19 by charge of 1 electron, 1.6022 into 10 to the power of minus 19. By solving, I am getting here as a 5. So number of electron is equal to how many? 5. So which is the method better you will think? You can go with this one. Is it clear? Right. But this one completely discovery of electron part I completed. Now in our next video, beta, we are going to see discovery of proton, because the length of this video is very much, means it is a more than 30 minutes over. In our next video, I will go with a discovery of proton and then discovery of neutron. Right? Thank you, beta. Thank you very much. Have a great day. Take care. Bye.